In section 5.5.57, a golf course architect has 7 linden trees, 6 white birch trees, and 4 bald cypress trees to plant in a row along a fairway. In how many ways can a landscaper plant the trees in a row, assuming that the trees are evenly spaced? Now, a permutation is an ordered arrangement in which R objects are chosen from n distinct objects, and repetition is not allowed. Now, the number of permutation of n objects, of which n subscript 1 are of one kind, n2 are of second kind, and all the way to n subscript k, is given by the following formula. So we have to determine the total number of trees that we have. So how do we figure out how many total number of trees that we have? Well, we need to add up how many that were given. So we know that there were 7 in the first linden trees, and then we have 6 white birch trees, and then we have 4 bald cypress trees. So when we add them together, that gives us a total of 17. So n is equal to 17. And then we're going to define what n subscript 1 and n subscript 2 and n subscript 3 represents. Well, the number of linden trees is n subscript 1, which is 7. So we can see here that the 7 linden trees is going to be represented by n1, which is 7. And then we have 6 white birch trees. So therefore, we can say that the number of white birch trees is n subscript 2, which is equal to 6. And then we have 4 bald cypress trees. So therefore, the number of bald cypress trees is n subscript 3, which is equal to 4. Therefore, to determine the number of different ways the trees can be planted, we're going to find the number of permutations of the 17 objects, which 7 are of one kind, 6 are of the second kind, and 4 are of the third kind. So using our formula, we have 17 factorial divided by 7 factorial times 6 factorial times 4 factorial, and that gives us the result of 4,084,080.